Happy New Year and welcome back to school. I am so looking forward to seeing you guys again and starting our second semester together. As we're now finished up with the first semester and we have some really robust data on your learning and progress so far, I wanted to take a moment to talk through the proficiency scales that we've been working on, the ones that we're going to look at for next semester, and what the information is about your learning and your progress that you can actually take from your grade. Because the grade, as you know, is not the be-all, end-all. It's just a measurement of where you are so far. And the nice thing is that the way that we are currently assessing and reporting out your information, there is a ton of data and a ton of information you can get from Aeries and from your grade in our physics and engineering classes that can help you figure out how you're doing and how you're progressing and where you want to keep working. So remember, our goal is always to help you continue to grow and become the person that you want to be. And this is one way that we can kind of help do that. So step one, processing through what these numbers in your grade actually mean. So as you know, we've been scoring everything on a 4-point proficiency scale. A level 3 is right on target. So that's kind of where we start from. That's where we're hoping that everybody gets in every category. That's where you are demonstrating mastery and proficiency through the work. A level 4 would indicate that you're demonstrating that mastery and proficiency, but you're also going beyond and above what has been taught. And then a 3.5 would be like you're always showing proficiency and mastery, and sometimes you're able to go beyond what's taught in that particular content area. Going down a step, a level 2 is the simple content, the details and procedures that are necessary to build the scaffold up to a level 3. So if you're doing the simple stuff, but you're not yet putting it all together, that would be like a level 2. A 2.5 is when you're doing all the simple stuff correctly, and sometimes you're getting to the mastery, and sometimes you're not totally showing that. And then a level 1 would be that you can do the simple work with teacher assistance. So if somebody helps you, you can get it done. You can see how that translates to grades. We've evaluated in 8 different areas in the first semester, and we're going to evaluate in 8 areas in the second semester as well. Each and every one of those areas, you had the opportunity to earn up to a 4 to demonstrate above and beyond. And the hope was that you demonstrated at least a 3, showing that you understood and mastered it. So let's take a look. This is a sample student's Aeries. And this is what you can get if you go into Aeries, you look at your grade in physics and engineering, and then you look at it by category. So there's a button to hit where you can look by category at what you're seeing. So things that I want to highlight, there are 8 different areas that you were evaluated in the first semester. Those are conscientious learning, communication, collaboration, engineering design cycle, data analysis, momentum, forces, and energy. Conscientious learning is your work in class and your consistent completion of work. This is the learning how to be a good student part. Are you on task, really focused? For this particular student, you'll notice that there are 2 columns. There's a summative column, and then there's a formative column. The formative was all of the scores throughout the year averaged. So all the scores in conscientious learning, and then they were averaged together. And you can see that this student had an average of 3.22. Then I went through and gave a summative score, and the summative score is overall, what has this student really demonstrated on their conscientious learning? This student was right on target. They were conscientious, but not necessarily going above and beyond. And so they earned a 3 for their summative conscientious learning. For communication, that would be both written, verbal, presentation, video work. We've communicated in lots of different ways. This student had an average of a 2.93, and that was averaging to a 3 summatively. Collaboration is, as you know, how we work together and work in groups. Engineering design cycle, that was demonstrated through your Rube Goldberg machine and through your alternative energy vehicle design. Data analysis was shown through the trebuchet work, where we analyzed some of your experimental data and made posters. And then there was also some data analysis on the final exam. Content for momentum. Momentum was shown in your physics of sports video, as well as your trebuchet work. And we had a couple quizzes. There was a test on it and part of your final exam. Forces were shown through our Rube Goldberg force quiz, through your Rube Goldberg work, through your physics of sports, and the final exam. And then energy was shown in your alternative energy vehicle. So each of these are worth a different percentage of your grade. And you can see that the way it works is that you get an average, and then I look at that average and convert it into the summative score at the end of the semester. So for this particular student, they did really strongly. They have, under the summative, great or right on target in conscientious learning, communication, collaboration. Obviously, there's still area to grow there. They could still work on going above and beyond, but they're right on target, demonstrating what is expected at the 9th grade level. Engineering design cycle, they did go above and beyond. They did some really strong work with the engineering on the alternative energy vehicle and on the Rube Goldberg. Data analysis was an area of struggle a little bit. So they had a few areas where they were struggling with the data analysis, especially on the final exam. So they're doing all the simple stuff. They're able to do basic analysis, but taking it to the next level is a little bit more difficult. Momentum, they're right on target, looking good. Forces, again, they struggle a little bit with the analytical and the calculation part of the forces. So a little bit of a struggle on the final exam and the forces test. And so that's why that is reflected as a 2.5. And then the energy content, their alternative energy vehicle really showed the energy content nicely. So they earned a 3.5. They went a little bit above and beyond. And you can see overall, when you average all of that together, it comes out to a 3.03, which is an A minus. Their average on just the formative stuff was a 2.99. After doing the rounding and my evaluation on where they really showed things, they were at a 3.04. And so that gives them a 3.03 overall, which is a solid 3 A minus. Okay, so you can look at this and really see which areas do you want to keep working on. This student would probably focus on data analysis and forces. Which areas did you really crush? This student did great in engineering design cycle and in energy. Each of these areas, you had the opportunity to earn up to a 4, a level 4, and there were students who earned a level 4 in each of these areas. Although I'm not sure if there's any student that earned a 4 in every single one of these areas, because they're diverse skills and we're all working on something. Okay, so how do we actually determine these scores? So here's a sample of 5 students. And these 5 students, I looked at, this is their communication scores throughout the year. You'll notice the very last column over on this side is their final communication score. That's the summative score. So for each one, I looked across the row and looked at where they really excelled and what the trend was over the course of the semester. So this first student at the very top row, 3.5, 3.5, 3.33, 3.53. So I said overall, every once in a while they're getting the 3.5, but by and large, they're hitting a 3. They're right on target. So that earns them a 3. The next student had a mix of 3s, 4s, 3.5s, a 2.5, and then 1 missing assignment. So their alternative energy vehicle, they didn't have the communication component there. Because of that mix, because there was some missing stuff, there was a 2.5 in there showing that like the writing wasn't quite where we wanted it, but their presentation work was really good. That gave us a 3. The next student had 3.5s, 4s, and a couple 3s. This student earned a 4 in part because the 4 work, especially on their physics of sports video, was so strong and it stood out to me that I knew this student was consistently going above and beyond. You'll notice there's 3 4s in there. That's a pattern of earning a 4 and going above and beyond. So that gave them the 4. The 4th student down, that's highlighted in blue, has some 1.5s and 2s in some written work, but did really well on the spoken work. They had a 4 for their last presentation. So again, that got us to kind of a 3 on average. I think if you look at this pattern, you'd say, okay, we need to work on our writing a little bit more. But the overall is pretty solid. And then the last student looking at 2.5, 3.5, a missing website, 2 3s for a presentation and some written work. another struggle with the writing on the website, and then good spoken presentation. So the spoken work was pretty good, 3s and 3.5s. The written work was at like 2s or so. And so I averaged that into a 2.5 because we still need to keep working on the written component of communication. So that's kind of where we went through this process. I went through and looked for the overall general pattern and trend line. In many cases, it's not super obvious. And so I had to make some judgment calls in terms of, is this student going above and beyond, or are they showing like meeting proficiency? In some areas, you met it here, but then we struggled in this area. So we had to kind of adjust. By and large, when I did this for every student across every category, no students went down in grade and some students went up in grade. So it ended up helping people overall. All right, so where are these scores actually based on? Well, as you know, every project that we did was evaluated in a number of different ways. So these are the last 2 days of class. This was your final exam and your final presentation, which was your alternative energy vehicle presentation. And these were scores that I put in from the final exam. And I evaluated the final exam in 3 different areas. There was an evaluation in the data and graphical analysis. There was an evaluation in momentum, and there was an evaluation in forces. So those were the 3 sections of the final exam, and they were scored separately. So the first person got a 3, a 3.5, and a 3.5 on those 3 sections of the final exam. The next person got a 3, a 2.5, and a 2 on those sections of the final exam. So you can see it was not the same pattern for everybody. The person second to the bottom went 4, 3.5, 3.5. The person at the very bottom went 2.5, 2, 2. So it was kind of all over the map. Then I also put in scores for your final presentation. And you can see just based on these scores, I was pretty happy with the final presentations. The first one is the conscientious learner. How hard were you working in class? And all of these students did really strong work in class. The next one is the communication. So that's the quality of the presentation and the speaking that you did during that presentation, as well as the visual aids. And this was a mix of 3.5s and 4s for these 6 students. The next column was the engineering design cycle work. So how strong was the engineering of your vehicle? Did it do what you wanted it to? And were you able to optimize that? And then the last column is the work on the actual energy itself. Were you able to make a model of the energy and able to show how it progressed over different meter marks and how the energy was transferred from a potential energy source to a kinetic energy source? And most students were able to go above and beyond in this area and show a lot of intermediate steps that really showed a strong understanding of energy and energy transfers. So that's great. So anyway, as I'm going through and evaluating each assignment, I'm evaluating it in multiple areas. So you can see in this, I evaluated in 8 different areas if you include communication or collaboration, which is not shown on this screen, but I also did a collaboration score just from this one project and the final exam. Okay, so where do these numbers come from? How do I know what's a 4 or a 3? That's all based on our proficiency scales. I'm attaching with this video the proficiency scales from the first semester, so you can look through and see how you did there, as well as the proficiency scales from the second semester, which are the ones that we're going to be working on this upcoming semester. Some of those are the same. We're going to keep working on engineering and data analysis and collaboration and communication and conscientious learner. And some of them are different. We'll switch out momentum, forces, and energy for gravity and orbits, waves, and electricity. So here's a proficiency scale for energy. This was the last one that we were working on your alternative energy vehicle. Our target, and these are also all in your physics core tools packet, San Marin core tools pack, the one with the physics everything sheet on the back. All of the page H's, there's H1 through 10, I believe, are all of the proficiency scales. So this is proficiency scale number 3, which was for energy transfer. The target was to show in a model the conservation of energy using both movement of objects, which is kinetic energy, and position of objects, which is potential energy. If you were able to go beyond that, the one that we really focused on was the top one. Can you show mathematically and in graphs where all the energy was converted at multiple intermediate time intervals? Those intermediate time intervals would be each meter of your object moving across the track. So each of the 5 meter marks, how is the potential energy being converted to kinetic energy at those points? And that's the big graph you did showing potential energy going down, kinetic energy going up and then back down, thermal energy rising, and the total energy staying the same. So many of you were able to hit level 4 here by following that proficiency scale and showing that information. And we have those for every single one of those 8 categories. Some of these look a little bit different. So like for conscientious learner and communication, this is also in your physics core tools packet. But these are the rubrics for your final product of your project. For conscientious learner, looking at what a 3 or a 4 or a 2 looks like in terms of process. For communication, what does expressing your ideas and communicating on target for a 9th grader look like, as opposed to going above and beyond? So exemplary means something that I would use an example, something that I could show other students as being like, hey, this is how you might think about going about doing it because they did a really good job. So that's kind of conscientious learner and communication. So that is all of the information that you can take from your grade. I spent a ton of time really thinking about each and every one of you and your progress in each of these areas. So I hope that you're able to go into Aeries, look through each category, see where you are this last semester, and set yourself some goals for second semester as you think about how you want to make progress to the next one. Because really, we have almost a full report card's worth of information in these summative scores. I would pay attention to the summative points earned or the summative average for each of those categories. That really shows you how you're progressing in all of these important areas in science and engineering. So good luck with that. I look forward to seeing you guys in class this week and starting work on our next project, which is going to be solving a world problem. All right. With that, I will see you soon.